So for this one, once again, we're going to start with that nice formatting of y equals a b to the x. And we got my first point, which is when y is 6, x is -2. And when y is 1, x is 3. So that means 6 equals a times b to the -2, which is the same as 6 equals a over b squared, because b squared with that -2 goes to the denominator. Now I can multiply both sides by b squared, and I've got 6b squared equals a. I've got enough now to do a little substitution. Check this out. I can plug in 6b squared in for a over here. And I've got 6b squared times b cubed, which is 6b to the 5th, right? We add the exponents. Then I'm going to divide both sides by 6. 1/6 equals b to the 5th. Last but not least, we're going to take the 5th root of both sides. And that means b equals 1/6 and the 5th root of that, which another way to say that is b equals 1/6 to the 1/5 power, right? The radical just becomes that denominator of the fractional exponent. Okay, and if I know that this is b, I can figure out what a is by plugging into either of these equations. Let's plug it into this bottom one. So I have 1 equals a times 1/6 to the 1/5 power, and this whole thing is cubed. So then now with the exponent rules, I distribute that 3 to that 1/5. So I have 1 equals a times 1/6 to the 3/5 power, which means a equals 1 divided by 1/6 to the 3/5 power, which is the same as a equaling, since it's in the denominator, it's the same as just saying to the 1/6 to the -3/5 power. Now I have enough, but this is going to look pretty messy. So we have y, or I'll say in function notation, f of x equals, and then first we have that a term, which is 1/6 to the -3/5, and then times b, which is 1/6, and that is again, b is to the 1/5 power, but then I need that x out there. So I can say 1/5 that to the x power, or times x, which is really just simplifies to x over 5. So here is that nice exponential function. It's quite complicated, but that's how you do it. Done.